Hello again. This is the second class of linked list. And on the first class, we have started to know what is the linked list, what are the basic activities. We have done 5 activities, if you can remember. So if it is your first class, I will just request you just to go back to the previous class because that will be the prerequisite for this class. And also you need to have a basic idea of object. So I will be pasting the link of both those classes as a dependency of this one. So you just need to go through that. Otherwise, the same thing I want to tell, linked list is entirely a new topic. So what I have experienced during the several years of teaching, like it requires a minimum time, like 3 full classes. Obviously, you have to try in between. It is not like if it take 3 classes, I'm not going to try. No, not like that. So you have to keep trying. So after 3 classes, then I see people have started to write the programs, write their first programs. Okay, order to understand what is really happening. Okay, so it is our second class. So I will not expect like you will be writing the full code for all the linked list things right now. But today our agenda will be just to check few programs if you are able to understand or not. No need to write by your own, just try to understand what I'm trying to write. So let's first start with some kind of revise what we did last week. So suppose if I ask you, count the total number of nodes which is there in a linked list. So let me go to the solution that we have started from the last class. So we created a linked list class there, and we have designed 5 different methods under that. Oh, sorry, where is that? I opened it, where it disappeared. Okay, no issue. Let me open it once again. Yeah. So what is happening? If I just make it, yeah. So now, yeah, here the linked list class, and we have designed something like insert at beginning, insert at ending. If you can remember, we have designed delete from beginning, we have designed delete from ending, and at last the display. So suppose if I want to add something like count here, so I can write something here instead of display. Okay, let me copy the display once again. So here I will write count. Count of nodes, how many nodes are there. So if it is null, then I will say list is empty, or I can simply print like I can simply print like no node, 0 node or something. So here I can define something like int count equals to 0, int c equals to 0 to count the number of nodes. Okay, so now, okay, let me delete this one. So what I will do, from the starting, I will define something, a temp, and from the starting, I will start from the head. Obviously, there will be some head. From the head, I will go till the null. The temp will start from head and go till the end. Every time it will do temp equals to temp dot next. And while doing that, I will just write C++ in between. And that's all. So after the loop has been done, I will just going to print the total number of nodes are something like C. Okay, total number of node is C. That's all. So I'm just going from the start to the end, and I'm just keep counting C++, or you can write C equals to C++ if you do not know what is C++. So the same thing. So now let me just compile that and let me check if it is really working or not. Let me create it. I'm not running the menu. I'm just creating an object for that. Let me create the object with my name, Guha. It is very simple. I hope you can understand that. You have started understanding all those things. So like if I start insert at ending, suppose I have entered 10. I am again running insert at ending and I'm entering 20. I'm again inserting at ending. So it is 30. So if I display, Now it will be 10, 20, 30. Obviously, you can see 10, 20, 30. So now I just want to count like, okay, I have 3 nodes. How to find that? So if I run count, it will give me the total number of node is 3. Got it? So that is how it is working. So I hope these things are becoming easier for you. So if it is becoming easier, today's class, I will go further. I will going to show you more tougher things so that you will be habituated with all these things. And after 3 classes, you will feel easier with this type of activities, with this type of requirements. So suppose before that, let me do another thing like yesterday's, like the first class, print the sum of all elements. So if they are asking for the sum, so what to do? So obviously, like count, I'm going to introduce another method that will be called as sum. Again, almost the same thing. Here I will write int sum equals to 0. It will go, it will traverse the full linked list. The temp will start from head. It will go till it becomes null. Every time temp will be going to the next node by temp equals to next. And here I'm not going to count anymore here. I'm just going to find sum equals to sum plus temp dot data. I just want to take the integer part of that, and I'm just using that inside the sum. So at the end, I'm going to print like the sum of all the node is sum. Sum of all nodes is sum. So I think it feels now okay for you. What I can understand, like these are very easier now. So if I just create a linked list with my name, and again if I start inserting value, let me insert 10, let me insert 20, let me insert 30, let me insert 40. And now if I want to get the count, okay, first count will be 4, obviously. And now if I want to get the sum, I'm not good in mathematics, but it will be around 100. Okay, 10 plus 20 plus 30 plus 40. Yeah, it is 100 itself. Okay, so that is how it is working. But I don't feel like, I think these things are becoming easier for you. So I'm not going into that direction anymore. On the first class, probably it was difficult for you how to print. We printed in the similar manner. So today we are counting in the similar manner. We are today getting the sum in the similar manner. So I guess these things are easier for you now. So go to our first topic. That's why I didn't put it as our first topic. So today we will do only 3 topics. So as a first topic, I'm going to add some more methods. Okay, just for a practicing purpose. So last week we have done this thing. So today we will going to add something like insert at a position. Suppose if anyone says like I want to insert something at third position, say suppose if I have something like 10, 20, 30 and 40 and 50 as well. Suppose if anyone says like I at third position, I want to add 100. So what to do? Or at fourth position, want to add 100. So what is the fourth position? So here at the fourth position, someone wants to add 100. So that is the thing. So it is the first position, it is second, it is third, and this is the fourth position. So at the fourth position, someone wants to add 100. So that is the requirement, how to do, how to deal with that. So first, obviously, let me copy something because I'm not good at typing. So let me copy insert at ending. And let me copy here with a name like insert at position. So here you can feel like we have to give 2 input. First one is position and next one is value, V for value. So obviously, as usual, we will create a box on node. Let me draw it first. I think that then it will be more easier for you to understand. Okay, let me add something very quickly. Yeah, suppose this is the existing linked list. Drawing here is very important, so I just took some time to draw that diagram. So suppose it is the existing linked list, and the first one is the head. So now insert at positions with the value given. Suppose they have entered like at the fourth position, they want to insert 100, suppose. So with taking that value 100, I'm going to create a box. Okay, suppose let's create a box like this. The next part of the box will be null as usual, because we have done the same thing in the previous parts. Here as well, if you see, name node box equals to new node, we have done the same. We created a box like this. Okay, so now if head is null, head will be that box. Else, or you can skip that part as well. If head is null, it depends, like if someone is saying like at the fourth position I want to add 100, if there is nothing, obviously we will not create anything. But if head is not null, okay, we can say like no linked list or something. System dot out dot println, we can say no list exists, something like we can print. But again, that is not the issue for the time being. Else, in the else part, what I will do, I have to somehow reach, till 30, means till the position 30, means I have to reach somewhere till here. Then only I can make a connection from here to here, and then I can do my operations, but I have to reach till 30 somehow. So what I will do, I have started the temp from head, and I have taken another variable called int p equals to 1, position equals to 1. I will keep iterating until temp becomes null. So, but I will stop it here, like if the position is equals to position minus 1. Because suppose someone wants to enter at fourth position. So I am targeting at the third position, I have to stop. So every time p is starting from 1, p is starting from 1. And every time I'm checking if p becomes 3 or not, means position minus 1. If p becomes position minus 1, I'm going to break the loop. Otherwise, every time p will be p plus 1. Every time p is becoming 2, but after that p is becoming 3, after that p is becoming 4, like that. But whenever p becoming 3, p equals to 4 minus 1, p equals to 3, I'm going to break. So in that way, the temp will be starting from head, and temp will be reaching till here. Let me draw. Yeah. So temp will reach to the third position by this way. So now think like a doctor. Think like a doctor. So what you need to do? So obviously, first thing you need to do to create a link between this to this, right? Some people do some mistakes. Some people first create the line between 30 and 100. If you create the line between 30 and 100, then you are going to lose all this, because obviously this arrow will no more exist. So you will basically lose everything after 30. So what you need to do first create a connection from here to here. So if you want to insert 100 in between, if you really want to insert 100 in between, first box dot next should point to 40, means 100 should point to 40. So what I will do, whenever I will break, after that I will write box dot next equals to temp dot next. So whatever will be written inside temp dot next, box dot next will take that. Okay, so that is the first thing. After that, obviously now temp dot next, I will make it box. temp.next, now it will point to box. Previously temp.next was pointing to 40, but now temp.next will point to 100. Just think like a doctor. Now it means we have added 100 in between 30 and 40, and that's all basically. Okay, so we have successfully added something in the middle. So let's try if it is really working or not. Let me close this one and let me go to the linked list and let me compile. Let me add first few. Okay, let me create a linked list with my name first. And here, if I insert something, let's insert 10, let's insert 20, let's insert 30, let's insert this, let's create the same situation like this, 40 and 50. So if I just want to display to be confirmed like we have created it successfully or not, yeah, 10, 20, 30, 40, 50. Now I am interested to insert something at some position. So it wants two value now. So at the fourth position, I want to insert 100. So now if I display, so it should be 10, 20, 30, and then 140 and 50. So now if I want to insert something like at the third position, I want to insert 200. So at the third position means between 20 and 30, 200 will be there. So let me check if I display. So here it is. So at the third position, 200 has been inserted. So that means it is working for all the values. And that is how you have to write your programs. You have to think about your solution if anyone wants to give something. But here we have to think more because it is our second class. So you have to think all the situations. So let me think about all the situations. All the situation means at best condition, it is working. But what will happen if I want to do something? Suppose if you have 10, 20, 30, 40, 50. Okay, let me clear the drawing. Yeah. So if you have 10, 20, 30, 40, and 50, what do you think? You have to think in this way. Suppose you are creating really some softwares. So people are not good users. You cannot expect a good behavior from the user. So what if user gives like, okay, I want to add 100 at 10th position. So is it possible? We do not have any 10th position. So that is some exceptional situations. On the normal situation, it is working. But if user is not good, user is trying to give some random values, how to behave with that? Obviously we will not going to say like, okay, our job is not working because you have given something wrong. No, we have to respond accordingly. You cannot just put the blame on the user. It is not a good software thing. Okay, because if I give some bad input into some of the application, phone application, or into the website, obviously they do not fail. They give some response like, hey, you are giving some wrong values, please give the valid values, please give the correct input, something like that. They give a message. So we will do the same thing. If someone try to insert something like 10 positions, 10, if that doesn't exist, I will give them some message like. So you have to think about that. Today's agenda will be something like that. So here, suppose if they give the position 10, obviously this loop will not break anywhere. So it will reach till the end. When the loop will be ended? When temp become null. If you are giving a good position, then it will be break in between and temp will be somewhere in between. But if you have given, suppose the position 10 or position 20, if that doesn't exist, the loop will be ended only when temp become null. During the display, we are running the same query until temp becomes null. So after the loop, we have to check this condition. If temp becomes null, that means you can say invalid position. You can say invalid valid position if 10 becomes null. Else, so there might be a lot of situation, even I cannot think. It is not always like it might happen, like I'm also not able to think all the situations. So there might be a number of situations you have to think. Whatever you are getting, you have to apply that. And that's why you have seen the versions of the phone applications are getting released after few weeks or after few months, in a gap of few months. Suppose sometimes in the Google, from the Google Play Store, you receive some message like, okay, you have to update your phone app. Why? Because they keep changing their code. Whenever they think something is wrong, they fix that code. Or someone, suppose out of millions of users, only one person face that situation. When they report like, okay, I'm getting some error when I'm trying to do this. So whenever the developers come to know like, okay, this is the situation where the problem is being created, they try to think over that and they put the solution. They added some extra lines of code or they fix that, and at that time they create another update or another new version of that same application, so that everyone else, though they didn't face the same error, but still they have to download the latest version, or we call it updating the app. Okay, so here the previous version was running fine, but if someone out of million user, if someone try to insert 10, and at the 10 position he's trying to insert 100, he or she will get the error. And that's where we need to make the changes in our code. We cannot say like, okay, user is wrong, user is giving the invalid input. We cannot say that. In return, in we rather we have to provide the solution so that our application stand tall. We shouldn't fail. We should give the correct message like, okay, invalid position. And that is expected from a application developer. So here I'm adding this line. Okay, what else can be happen if anyone says like, I want to insert something at position 1. At position 1, I want to put 100. So what I need to do? So here I need to add something like, here if, okay, if I can write, else if position is equals to null, equals to 1, then, okay, first if head is null, there is nothing, and someone is saying I want to add 100 at position 1. If that happens, then I will say head equals to box. But if anyone say like head is null, and if they say I want to add at position number 3, so if it is not equals to 1 at that time, then I will say like it is not possible. If there is nothing and you are trying to insert something at position 3, it is not possible. So I can simply write. So that's how you have to think more. So you can write that is not possible. Something like that. If there is nothing and if you want to add at position 1, then it's fine. But if you want to, there is nothing, and if you want to add something at position 5, it is not possible. Else, if someone, suppose head is not null, head is not null, and you want to put some, suppose, and at that time anyone some wants to put something at position 1, what you need to do? So there is something like 10, 20, 30, 40, 50. And if someone wants to insert something at the position 1, then you have to write box dot next should be head, and head equals to box. You have to reuse the same logic we have written here. We have to reuse the same logic here. So position 1 means basically it is, they are saying insert at beginning. So you can write this, the same code here. Box dot next equals to head, head equals to box. You can see the same code. You can write it here. Got it. So let me try again now. So if I compile and let me try to play with that. So if I go to the blue Java and let me, we have thought quite a lot of situations. Let's see if it is now working or not. Let me create a linked list with my name. And first, let me call insert at position. I'm saying at the fifth position, I want to put 100. There is nothing. So it is saying that is not possible. Obviously, I have nothing and I want to insert something at position 5. But if I say like, okay, I know there is nothing. So I want to add 100 at the first position. What it will do? It will be added. Okay, it is not showing any message. If I display, it is showing one node with 100. Now, if I want to insert, suppose at ending, suppose let me add 10, then let me add 20 at ending. So now we have something good. So if I check, we have 100, 10, and 20. Now, if I want to add 2 at position 3, okay, sorry, I want to add 200 at position 3. So let me do that. Our normal thing at position 3, I want to add 200. Our normal activity in insert at position, that is the normal one. So if I display, obviously simply 200 will be added at the third position. We have already tested that. But here I want to test something, the exceptional situation. So if anyone think like, okay, I want to add at the first position, again, if I want to add 500. So now head is not null. We have a particular list. And at that time, I want to add 500 at the starting. So obviously 500 should be added at the starting. Let's see. So look, it is working. So think about more situations. If you feel like, okay, there might be more situations like this, just write a comment here, like with that situation. Suppose you have this. Suppose you have a situation like you have a linked list like 10, 20, 30, 40, 50. And at this time, what will happen if I want to add something at 20th position? So tell me about more situations. But for the time being, I can think only this. So that's all for the time being. Let's proceed. Okay, but the situation might be many more. Probably I'm not able to think, but there might be many more. So next, if I go for a delete from a position, suppose you have a good linked list and you want to delete something from there. Let me try to draw a good linked list first. Let me go back very quickly. Yeah. So here we have something like this. And if anyone asks like, okay, I want to delete from position number 4. That means I want to delete from position 4, means I want to delete 40 basically. So what I need to do, I need to do, I have to somehow reach until 30. So let me copy that. So let me copy something like delete from ending. Let me copy this one. Yeah. So I will write delete from a position. And here, obviously, they will give me an input like P or pause. So if head is null, nothing to delete, obviously. If head is not null, then I will write temp2 something. Temp2 is not needed, probably, or let it be there, temp2. So here what I will do, temp equals to head until temp becomes null. And I will keep going like temp equals to temp next. And here I will define something in the similar way, like I have done for insert at a position. Same, I will introduce a variable called P. And every time I will keep checking if P become 3, means position -1. Position was 4. Suppose if anyone wants to delete fourth position. So I will keep checking if P becomes 3 or not. If P becomes 3, I will simply break that loop. Otherwise, every time it will be P equals to P plus 1. So when P becomes 3, I'm breaking the loop. So temp obviously will reach here. Temp will reach here. So what I will do next, I will find after the loop, first task will be if temp become next, if temp becomes null. So obviously that means someone made some joke like, okay, I want to delete the position 100. So I will write here system.out.println and I will just write something like invalid position. But if there is some good value available for temp, that means we are somewhere in between. So what I need to do at that time, let me show you. Okay, somehow I'm writing something not good. Else, yeah, here the else will be. Okay, let me delete this. I will not going to need these lines. So now I am at this position at temp. So I'm going to write temp2 equals to temp dot next. So that means the next node will be named as temp2. After that, I'm going to write temp3 equals to temp2 dot next, obviously. So you can write temp3 equals to temp2 dot next. So now what I need to do? Okay, I need to introduce temp3 node temp3. So now what I need to do? I need to create a direct link from temp1 to temp3. Simply because I want to delete the value of temp2. I need to delete the node temp2. So I'm creating a direct link from here. So I'm writing temp dot next equals to directly temp3. No more temp2 will be there. So now temp is pointing to temp3. Obviously temp will not point to temp2 anymore. Okay, sorry, I deleted that. So let me write temp once again. Yeah. So now what will be the next task? Think like a doctor. So you have to delete the link between temp2 and temp3. So I am writing temp2 dot next equals to temp3. Equals to null, sorry. So that I'm removing. So that means if I draw in the picture, if I update the picture, temp2 and temp3, the link between them will be disappeared. So now I'm going to write system.out.println. Temp2 data is deleted. That means it will print 40 is deleted. And at last, you can write temp2 equals to null. So that means temp2 will be disappeared from middle. Sorry, something else is being deleted out. Okay, something else is being deleted out. Okay. Anyway, so I'm just trying to delete 40 totally, something like that. Okay, so 40 will become null. So that's what I have to do. If anyone is looking for deletes from some position. But in the interview round, if they ask, you can simply mention this query only. Okay. If anyone asks during the interview, like what is the solution for insert at a position, do not think about all the exceptional situation. Simply write the code, this one. Okay. Or algorithm. I will show you later what is an algorithm called. But for the time being, if as we are good in programming, so we are writing all the codes by ourselves, you can just try to understand what is the code. That's all. What is algorithm, I will tell you later. But I'm talking about these special conditions you do not need to think about. If anyone asks like what is insert at position. Okay, so you have to tell the normal situation. Exceptional situation, you do not need to tell. Same for delete from position. There might be some exceptional situation like when head is null, someone is trying to delete something. Even someone might try to delete from the position 1 as well. If they say like, okay, I want to delete from position 1, what will happen in that case? So obviously, I will check. If head is null, then there is no chance to delete something. But otherwise, if head is there, and if anyone says like I want to delete the first position, so either you can copy the code of delete from beginning. Actually, they are saying delete from beginning. Either you can copy the code or you can copy simply the function name and you can call it here. So two options. That is how you can reuse the code. You do not need to copy one by one. You can simply call delete from beginning. That's all. If anyone is trying to delete from position 1, you can simply call that function. And that's how you can reuse the thing. Let me compile. And if I now go to the blue Java, and if I just try to create a new linked list by my name, and if I just write something, suppose, okay, let me insert first 10, 20, say 20, say 30, and 40. I generally prefer to create a long linked list. Then it will be easier for me to understand how the for loop is moving. Otherwise, with a small linked list, it is very small to start and end. That's why I prefer a long one so that I can think more. So now I have a linked list 10, 20, 30, 40. It is though not long, but still I can manage with that 10, 20, 30, 40. So now if anyone says like, okay, I want to delete, okay, let me write where it is. I want to delete from position 3. So 30 will be deleted. Yeah, it is also printing the message 30 is deleted. So it is working correctly. If I display, you cannot see 30 anymore. Perfect. And now if I just delete from position, if I write 1 position, so obviously 10 will be deleted. Yes, it is working fine. I didn't write the code for the same. It is simply calling insert at beginning, sorry, delete at beginning. So now if I display, it will be 20 and 40. So that means it is working fine. So here I have just reused the previous function. If anyone saying they want to delete from position 1, basically he or she is expecting delete from beginning because position 1 means beginning, and I can reuse the code in this way. And that's also in our agendas today, how to reuse the existing methods. That is our goal as well for today. So before moving to the next one, I can do another thing here. If you want, you can put something like this. Here I have written temp3 equals to temp2 dot next, but you can write alternative code. You can also write something like temp3 equals to temp dot next dot next. It means temp next of temp next. You can also write that. So it is next to next of temp, or you can simply write in this way as well, whatever you prefer. So we can write this code as well. Okay, I will share the code. I will try to share the code with the description, but that is how we will solve this. Okay, if you feel this stuff, you can go for this one as well. But yeah, it is good to know like we can write this type of symbols as well. If you want the next one, you can add another next here. Okay, but for the time being, I just want temp3 as next to next of temp. Okay, so suppose here temp will be 30, temp2 will be 40, and temp3 will be 50. So in that way, we can achieve that. Got it. So the last one for the day, suppose if anyone is saying delete a value, what to do? Suppose they are not mentioning the position so that we cannot stop at the previous position. They are saying, I want to explore, I want to delete something by value. So obviously, what to do? We have to check the value always. So suppose if I am writing delete from value, so here people will be giving me the value, val. So now if head is null, obviously we cannot delete something. If we found head.val, head.data is the value itself. So obviously we will delete from beginning. If the first node head contains the value, I will delete from beginning. Obviously, that is the exceptional situation. But for the time being, what I will do? Okay, I will start from, remove this. I will start from head. I will go until temp become null. And every time I'm checking if temp dot data equals to val. If temp dot data equals to val, I will break immediately. I will break immediately if temp dot data equals to val. So let me go to the previous drawing very quickly. Let me move here. So suppose I want to delete 40. So whenever I get temp equals to temp data equals to val, means whenever temp, the data of temp becomes 40, it will break. So temp will rest here. Temp will stop here at 40. But if I want to delete the node of 40, we have checked, we have to somehow stop at 30. So how can I go to the previous step? You know how to go to the previous node. We can do something like temp2 will also start from head. We did it in the last class at the time of insert at ending or delete from ending, I guess. Yeah, it was there at delete from ending. We have done the same thing. So whenever before moving temp to the next node, I am taking a copy of temp into temp2. Whenever I'm moving temp to the next node, before moving, I'm just taking a copy of temp inside temp2. So temp2 will hold the value of temp or will hold the node of temp, and temp will move to the next one. So when temp will reach here into 40 part, so temp2 will still be waiting here. Temp2 will still waiting here. Okay. So now what will I do? So first I will check if temp becomes null. So it is invalid position. Otherwise, I will define something like temp3 equals to temp dot next in case of delete from a value. Yeah. Delete not from value. I will write delete by value. So here temp3 will be the next one of temp. So I can write here temp3. So the same operations I will do again. So here temp2 next will become temp3. So temp2 dot next equals to temp3 means what I will do? I will simply create a connection between temp2 and temp3. So temp2 next becoming temp3 here. So let me remove the connection between temp2 and temp. And next I have to remove the connection between temp and temp3. Listen very carefully. So here I will write temp dot next equals to null. So now I will say temp data is deleted and I want to make temp totally as null. So that's how I can delete the temp. Let me try to execute. Let me check as well if it is running fine or not. So you have to think very slowly. Do not try to make hurry. Do not make any mistake. Just do it very slowly. So if I now again insert few things like 10, like 20, 30. Let me insert, let me create a linked list, a quite long linked list, 10, 20, 30, 40, 50. So if I display, so it will be like 10, 20, 30, 40, 50. Now, if I delete by value, what is the delete by value? Yeah, here it is, delete by value. I want to delete the value 40. So obviously 40 is deleted. So now it should show me 10, 20, 30 and 50. Yeah, it is doing that. So that means we have successfully deleted 40 from here. Okay, so that's how we can delete a value as well. Got it. You have other options as well. I want to show you how to know how to access next to next node. We have already done that. If you remember, we have just did that here. Temp next to next. I'm talking about this one. Next to next nodes. So that's we can achieve here in this way. If I can apply the same here, I do not want to take temp to head. You can apply it here as well. I do not want to iterate with temp and temp to both. I can simply write where temp dot next, sorry, where temp dot next dot data is val. I mean, suppose temp is at the first position and it will go to the next node and check if it is 40, the next node is 40, no, then move forward. So temp will go forward and temp will reach at 20 and it will check the next node of temp is having data 30, answer is no. So it will go next. So it will stop here, temp will stop here and say the next node of temp contains 40, answer is yes. The next node of temp contains 40. So what we need to do? So that means temp will stop here. Let me draw. So temp will stop here. Why? Because temp next data is 40 now. Look, temp next dot data is 40 now. So it will stop here. So if temp becomes null, obviously it is invalid position. Otherwise, I will design all this in different way. So temp2 will be temp dot next. Temp3 will be temp dot next dot next. So this is how you can use dot next these methods as many times as you can. So now I will write temp2 data is deleted. Okay, before that, so temp2 equals to temp dot next. That means temp2 will be resting here. Temp3 will rest here. You can see in these two lines, temp2 is the next one of temp and temp3 is the next one of temp. So now what I need to do? The simple steps like a doctor. Temp dot next equals to temp3. Temp next will directly point to temp3. Temp2 dot next will become null. And we will say like temp2 data is deleted and temp become null. So temp next equals to temp3 means we have done several times. Again, another time, temp next equals to temp3. So it will remove the connection between temp and temp2. And next line is temp2 next equals to null. So temp2 will become null. And after that, I will print temp2 data is deleted and temp2 become null. Sorry. Yeah. So temp2 will become null. So that also you can do like next to next method, whatever you want. You have several options, whatever you want, you can do. So that's what I was telling about. Okay. So this is the topic one we need to do. Okay. And we have three different topics I will say here. So you just need to think about all this. Okay. So if you have any doubt, you can tell me in the comment sections if you are not able to think about that. If you are still not able to understand, I will try somehow to make you understand these things. So we have a pretty good exercise for that. You can go through that exercise as well. We have a couple of menu for the link list. So you can go through that. If in case of any problem, obviously let me know. Otherwise, in the next class, I will discuss more about the link list. So the exercise you will get it from this Facebook group and the study materials also you will get. In case of any problem, just let us know in this comment section. We can discuss more about this. And that's all for the day. Okay, see you with another class of link list soon.